The lesson you need me to slow down or go back, you'll have to unmute yourself to let me know, as I can't see the conversation thread that goes on over on the left-hand side here while I have the notes pulled up. So if we start over on Canvas today, remember to be clicking on that attendance link every day before noon. If you click on the e-learning, you will see, again, there's first period and third period live Skype links there. You can always click on those to join Skype. But here we're live at 10 o'clock. And we're going to give a new lesson that's titled 7-4, Volume of Rectangular Prisms. I would like you to take notes in your notebook. And then after the lesson, there is one Khan Academy assignment. And I don't have that live yet. I will assign that as soon as the lesson's over today. I put a little note. This was the video from first period that says, I think I goofed twice in this video and no one corrected me. See if you can find my mistakes. So I'll leave that up until we get through this lesson. And then once this lesson's done, I'm going to upload this one instead. Okay, so I hope there aren't any questions, or if there are, again, you need to unmute yourself and let me know. So today's lesson is 7-4, and it's titled Volume of Rectangular Prisms. So this Unit 7 in Open Up Resources, or OUR, is more of a geometry-based unit. So we went over some angle things the last few weeks, and now we're going to focus on some volume and surface area over the next several days before we move on to the next topic. So again, 7-4, Volume of Rectangular Prisms. Okay, so first is, what is volume? I would like you to write this definition in your notebook. Volume is the number of cubic units that can fit inside a three-dimensional shape. So the first thing about volume is that when we talk about volume, we are talking about three-dimensional shapes that have a length, a width, a height, 3 dimensions. And volume is pretty much how much space fills up the inside of that shape. So if you think about maybe like a fish tank, how much water does a fish tank hold? How much coffee does a coffee cup hold? Those are examples of volume. Hang on just a second. Can't hear. Okay, leave and rejoin. That usually fixes it for everyone who can't hear. So from here on out, if you ever can't hear, try leaving and then rejoining. I didn't realize her little message popped up there. That was kind of cool. I could see that in the middle of this lesson. So again, a fish tank, a coffee cup, those are examples of volume. And it's literally like taking these little cubes that you can see over here in this image and just stacking them all directions and how many can fit inside a particular shape. Another important thing about volume is that all of our answers are labeled using cubic units. So what does that mean? That means that if you have something like an answer of 27 feet, you would say 27 feet cubed. And we use this little 3. It's an exponent. It's raised kind of like a 2 is when you square things. So if our unit was centimeters, we would say centimeters cubed with the little 3. Okay, so let's look at an example using this box down here in this lower left-hand corner. So for the formula, which I also would like you to write in your notebook, to find the volume of a rectangular prism, and that's what these are all called today. We're working with rectangular prisms. You oftentimes probably call them boxes, but that's the shape we're focusing on today. The mathematical term is a rectangular prism. All we have to do is multiply. So the formula, which again should go in your notebook, to find the volume of a rectangular prism is to multiply the length times the width times the height. And you can see down below in this bottom formula that we've abbreviated using the lowercase letters L, W, and H. Yes, the letter L does look like a 1, so oftentimes you'll see a cursive L. That's what you'll see me use today a lot of times, is a cursive L, so that there's no confusion. So in this example over on the left, we're given the height, 3 blocks, we're given the width, 5 blocks, and we're also given the depth, which in this case would be our length, of 4 blocks. So to solve this problem, we would plug in 4, 5, and 3, multiplying those 3 numbers together. 4 times 5 is 20, and 20 times 3 is 60. It doesn't really say over here what the units are, so really that should probably just say 60 units cubed, or we can just pretend these are a 1 centimeter cube. So then we know then that our units are centimeters, so we would say 60 centimeters cubed. So this was just an example for you to see how the formula works before we go on and do some practice. Are there any questions here? If there are, please go ahead and unmute your mic and let me know. If not, we're going to go ahead and go on. Okay. So for the first example, we're going to calculate the volume of this rectangular prism. Remember, if you want to draw a picture in your notebooks, you can kind of draw a quick rectangular prism. It doesn't have to be fancy or perfect, depending on how you want it to look. A lot of times we just draw 2 rectangles that are about the same size and you stagger them, kind of how I have them staggered, and then you just connect their corresponding corners. So there's kind of a quick way to draw a rectangular prism. I'm not wasting time with dotted lines because oftentimes you can draw rectangular prisms. I'll kind of show you here. You can draw some dotted lines that makes it look a little better because technically those dotted lines are kind of in the back of that box that you wouldn't really see them, but you don't have to get fancy here. So volume of a rectangular prism, length times width times height. What's nice about volume here is that these numbers really are all interchangeable. We'd probably all agree that the height of this box is 4. Length and width you can interchange, maybe just depending on how you're visualizing that box, if you're rotating it in your head or not. But 4 times 6 times 4, when you do it in any order, will give you the exact same answer. And so you're welcome to use a calculator. 8 times 6 is 48. 48 times 4 is 192. And then we want to say centimeters cubed because we have, again, that 3-dimensional shape that we're working with. So we're cubing the units. Okay, let's go on to the next example. Next example, another rectangular prism. Does anybody know another name for this shape? And if you do know it, how do you know it? You'd have to unmute yourself here if you'd like to share.
Isn't it a cube?
Mm-hmm. And how do you know that, Allison?
Because it's a square.
How do you know it's a square?
Because it has 4 sides that are the same.
Okay, there we go. So the dimensions of this rectangular prism are all the exact same. So because it's a 3 by 3 by 3, that makes it a cube. Volume, though, is still calculated the exact same way. We're going to measure the length times the width times the height. 3 times 3 is 9. 9 times 3 is 27. So we get 27 mm cubed. Who knows what mm stands for?
Millimeters.
Yeah, who is that? Is that Manny? Maybe?
Yes.
Okay, cool, right on. Yes, millimeters, good. Plickard would be proud because I think she went over the metric system earlier in the year, but those are millimeters, super, super tiny, smaller than a centimeter. Okay, any questions here? If not, we'll go on to the next example. Here we have another rectangular prism, not a cube. The dimensions here are not the same, so we don't have a cube. And these units are in feet, so if you're trying to imagine maybe how big this is huge. This is like the size of a room, a house, something, a building. The 40 feet is really long. But again, volume still calculated the exact same way. It's still length times width times height. And again, depending on how you're looking at this shape, 40 and 10, one's length, one's width, it doesn't really matter which is which. We would probably all agree that 26 here was the height, unless, of course, you're visualizing this shape maybe laying down. But grab your calculators here because it's 40 times 10 times 26. And the answer here is 10,400 feet cubed. Again, those units are super important. I think as you're working on Khan Academy today and you're calculating the volume of some of these rectangular prisms, I think what it's doing is putting the units on there for you, and it says units cubed, I believe, on your answers. So you don't actually have to type in units, you just have to type in the correct digit. Okay, so that's 3 examples where we give you all 3 dimensions, you multiply them together to find the volume. Now we're going to look at a different type of example. So not only is this my absolute favorite cereal in the whole wide world, but now we get to do a really fun math problem with it, right? If I had to pick one cereal to eat for the rest of my life, this would be it, for sure. Okay, so Lucky Charms box of cereal is 20 centimeters long. I'm going to go ahead and label that up here, 20 centimeters. It's 5 centimeters wide, so that's that real skinny part of the box over here on the side. That's I'm down here at the bottom. That's 5 centimeters width. It says that it holds 3,000 cubic centimeters of cereal. Okay, that's not the height. It holds 3,000 cubic centimeters. That would be cubic. That's tipping us off that this is actually the volume. And the question is, how tall is the box? So this is a second type of example where instead of needing to calculate the volume, we're given the volume. And now we have to find one of the 3 dimensions. We're still going to use the same formula. Volume equals length times width times height. And I'm actually going to write it out here so you can see where I'm kind of plugging in some of these numbers. Again, there's my use of the capital or the cursive L. So volume here, 3,000. So we're going to plug 3,000 in for the volume. The length, we're told it was 20 centimeters long. So we're going to put 20 in for L. We're told that it's 5 centimeters wide, and the height is what we don't know. We don't know the height, so we're going to put an H there. And now we're going to calculate or solve this equation. When you have an equation, the first thing we always should check is that we can clean stuff up. So I'm going to keep 3,000 over here, but on the right-hand side, I can multiply 20 times 5. And 20 times 5 is 100. So I get 100 H. And now we have 3,000 equals 100 H. This is multiplication over here. So remember from solving one-step equations that we get rid of multiplication by doing the opposite. So the opposite of multiplying is dividing. So we're going to divide both sides by 100. Again, you're welcome to grab your calculator. 3,000 divided by 100 is 30. I think this was my first mistake in first period. I think I said 300. But the question here is, what units do we use? So this isn't volume. The volume is not 30, so we're not going to say centimeters cubed. What we want to do is go back over here because this is just a simple dimension of the box. It's the height of the box. And so for the height, we just say centimeters. So only when you're finding the volume or actually calculating what the volume is, do you use a cubic unit. If you're just trying to find one of the 3 dimensions, we go back and just use the unit. In this case, it's centimeters. Okay, let's look at another example. Now we have a Kleenex box. It says the volume of the Kleenex box is 72 centimeters cubed. Okay, so we know that the volume is 72 centimeters cubed, and it's asking us for the depth of the box in centimeters. So you can see down here, it's the depth here that we don't know. So we know width, we know height, We don't know length. Or again, it really doesn't matter which letter you're plugging that x in for. So we've got 72 for our volume, 72 equals. Earlier we used depth to describe length, so I'm going to put an X here. You can still use the letter L. Maybe I'll just do that instead. I'll still use the letter L. That's the one that's unknown. And then we have a width of 6, and we have a height of 4. So on the right-hand side, again, we want to multiply those two numbers together. And I'm going to write 24L instead of L24. Remember that typically when we write a number with a variable, we always put the number first, but the variable second. So 24L instead of L24. Again, though, this is multiplication, so we're going to undo multiplication through division. 72 divided by 24 is 3. I've now done this problem enough that I remember that answer from earlier today. So the length is 3, and we want units on this. We can go back over to the box and look at the picture. You can see it's being labeled in centimeters. So 3 centimeters for the depth or the length of that box. So now we've looked at examples where we want to calculate the volume. We've looked at 2 examples where we know the volume and we're trying to find one of the dimensions. And now we're going to do kind of a challenge question. So if you were asked to find the volume of this shape, and if we were sitting in class, I'd probably give you some time to try to discuss it with each other. But if you were trying to find the volume of this shape, you quickly realize that there is no formula for the volume of an L-shaped, 3-dimensional, I don't know, block. It looks like the block letter L. There's no formula for that. So we do something called decomposing, which means we're going to break this piece up into smaller pieces whose volume we can calculate. And once we do that, and we have the volume of different pieces of this shape, we can add all of those volumes back together to get the volume of the big shape. So hopefully looking at this, and there are lots of ways you can split this up, but hopefully looking at this you can see there are probably 2 fairly common places where a student or where we might try to split this. I might draw a line across the shape here, and it splits it into a rectangular prism down below and a rectangular prism across the top. That's one way to split this figure. Another way to split this figure would be here. And again, that creates this really long rectangular prism on the left and then a shorter rectangular prism over on the right. I'm going to go ahead and just leave it like this, and I'm going to label these shapes 1 and 2. That just helps us keep organized so that we realize, okay, I've got 2 different pieces here whose volumes I need to calculate. So again, our final answer is going to be the volume of the shape 1 plus the volume of shape 2. So the volume of shape 1, that's this one over here on the left. It's 38 long. It's 11 wide. You can see that labeled across the bottom. And now the question is, what is its height? Again, if we imagine this shape kind of laying down on a table, this would probably be the height. So what is it? Well, it's not labeled here. In a figure, an example like this, they're always going to give you enough information. They might not write it everywhere. So now we kind of have to look around this shape and try to decide, okay, how tall is this shape? And you can see here that it has this inner corner height labeled as 10, which means it's also a 10 here. So now I'm going to relabel that 10 meters. So the volume of figure 1 is 38 times 11 times 10. So we grab the calculator, we do 38 times 11 times 10, and we get 4,180. We're going to label it meters cubed. So the volume of that rectangular prism on the left-hand side is 4,180 meters cubed. And I think that's the second place I messed up in first period, because I didn't remember that answer either when I went on to teach this in second period. I thought, wait a second, that's not what I got first period. And now we have to calculate the volume of the second shape. So the volume of that second shape, again, we want to figure out its dimensions. We can see that it's 19 across. It still has the same height of 10. Again, if you imagine this shape laying down on a table, it has a height of 10. And now we have to figure out what is this dimension here. We need, if we know this length, what is the width? And now as we look across this shape, we can see, and I'm going to use a different color here, you can see that it's not labeled anywhere. It's definitely not labeled here, and it's not labeled here, and it's not labeled here. These would all be the same number if it was labeled. It's not. But again, they're not going to give you not enough info. They've given us enough information. And what we're going to do is look here at this side, this one at the top left. So if I know that this whole length from this top corner here all the way down to the bottom is 38, that means from this top corner here all the way down to the bottom is also 38. And what you can see is that we know a portion of that is 27. So if part of it's 27 and the whole thing is 38, we do 38 minus 27 to get 11. So we know that this measurement here is 11 meters, and that would be true here, 11 meters, and here, 11 meters. So now we can calculate the volume of that second rectangular prism. It's 19 times 11 times 10. So we multiply those three numbers together, 19 times 11 times 10, and we get 2,090 meters cubed. But again, these aren't our final answers. The final answer is what's the volume of the whole figure? And the whole figure is 4,180 plus 2,090. And so now we add those two numbers together and we get a total volume, I'll write it over here on this line, 6,270 meters cubed. So this one is a challenge. It's taking what we've learned in the first part of the lesson and then applying it to a bit more difficult problem. You're not going to see anything like this yet on your Khan Academy today. Your Khan Academy is just asking you to calculate volume. So if you have questions while you're working on Khan Academy, remember that you'll probably need to take a screenshot and send it to me in an email. Math 7 has one lesson to do titled Volume of Rectangular Prisms. Remember that all of your homework and assignments are due by Monday at noon. So I'm going to go ahead and get out of this, and I'm going to stop recording.